Alright, today we're going to be looking at section 5.5, substitution rule. With this, we start out with the discussion of not all functions are easily integrated. So we start out with something that we're familiar with, and then we work our way up. This led us to using the chain rule and discovering how to integrate using substitution. These are the kind of backbones and the setup of the structure that we're going to be looking at when we're integrating using substitution. So theorem 5.6 is the substitution rules for integrals. And basically it says we're going to let u, which is a different variable we're going to introduce, equal to the function g of x. And g of x is differentiable and continuous. When we integrate f of g of x times g prime dx, that's going to give us f of u du. And so this kind of explains the substitution rule. Again, that's not easy to follow, but I'm going to show you how to do that in a little bit more detail. But basically, here's what we get. We have a composition function. We're going to identify the inner function. We're going to let that be u. We are going to do the multiple of that, the constant multiple, which we're going to take the derivative of the u, or the g, and replace that in our integrand. And so once we have u and the derivative of u, or g and the derivative of g, we can now evaluate the new integral with u, and we'll be using the power rule. And so it's going to make it a lot simpler and nicer to work. Usually what happens is that inner function, you can take the derivative of it when you set it equal to u, and it will be a part of that function already. So most of these are set up to work out for us in that way. Here are just some examples showing you how the substitution rule is going to be used. I will be modeling these in just a moment. But here again, just more examples, some with trig functions, more examples. Sometimes you might have to try different methods or different u's. It's not always clear what you should use for u, but with enough practice, you'll get a lot better at identifying I should use this for u to simplify my problem. Again, several more. We have these square root functions, general formulas for indefinite integrals are given here below. So sometimes we can just use a formula for some that we already know the integral of, especially the trig functions. They're also in our trig cheat sheets, but again, several of them are listed here. So become familiar with them if you can. Again, several examples showing you how to use this substitution, multiple problems, multiple functions. Then we get to definite integrals, where we want to evaluate the specific value. This talks about when we use substitution, sometimes we will also need to change the limits of our function. So going from g of x to using u, we would have to plug in those limits to that new function and then come up with new limits. So this is again explaining that process, how they're coming up with the new limits of integration. Here again are some examples, and this is one that I'll just kind of point out. So in A, if we're going to let u equals x plus 3 and we're integrating from 0 to 2, then we will need to plug a 0 in for x, solve it, and get what the lower limit of u is, and then plug in a 2. And that's what they do here. So plug in a 0, we get a lower limit of a 3. Plug in a 2, we get an upper limit of 5. And so instead of going from 0 to 2, we will go from 3 to 5 with u being our variable. And so just be aware of the change of limits. Sometimes that applies when you're doing substitution and doing a definite integral. And here's some more examples using some trig functions as well. And then we also have geometry substitution. So if you want to again view a problem where we can find that area under the curve using geometry, Here's an example of that. But with that, we're going to go ahead and jump in and solve some problems.